Hello again, everyone. We are checking in here and ready to start our next lesson on dividing rational expressions. This should be a pretty quick one because dividing, if you remember, when we're dividing fractions, we're following very similar rules to multiplying. So we're going to have a really quick step through here on how to divide rational expressions. So to begin with, we're going to talk about fraction division. And if you remember, fraction division, we used a three-word phrase to help us remember how to divide. And those three words were copy, dot, flop. So we are going to copy down the first fraction 5/8, change the division symbol to a dot, and multiply. So let's see what that's going to look like. So that became 5/8 times 16/15 when we went ahead and rewrote it with copy dot flop. After we copy dot flop, we always want to reduce fractions before we multiply, just like we did yesterday. So you want to cross reduce between the 5 and the 15. They can both be divided by 5. So we can go ahead and reduce both of those by 5 by crossing off the 5 and crossing off the 15. We can say 5 becomes 1, 15 becomes 3. Sorry about that, using the wrong tool here. Trying to get used to drawing with my fingers again. And if we go ahead and make that 15 a 3, there we go. We also can cross reduce the 8 and the 16. 8 and 16 are both divisible by 8, so I can cross off the 8 and turn it into a 1. And 16 divided by 8 is a 2. So we reduce everything we can on top with everything we can on bottom. Now, the final step is to multiply across. So we do 1 times 2 is 2, 1 times 3 is 3, and 5/8 divided by 15/16 is equivalent to 2/3. Nothing we've done here should have been new or radical to you, just a review of how to divide fractions. So now let's look at applying that to a division of a rational expression. Alright, so we have a rational expression example in front of us now. And this is obviously more complex than basic fraction division, but the same rules apply. Step 1 for any fraction division problem is going to be to copy, dot, flop. So we need to take the first fraction and leave it the same, and then flip the second one, changing to multiplication. So we end up with something that looks like this. So you see our flipped version, where we go ahead and, whoops, it looks like I made a mistake there. I left that as a division when we need that to be a multiplication. So let's go ahead and try this again. There we go. Now we have a multiplication symbol in between. So we have copy dot flopped, our division problem. And when we think about our fraction example that we did before, the next step was to reduce. But as we've learned over the last couple of days, we've spent now 4 days factoring and reducing fractions. We know before you can reduce these rationals, we're going to have to factor. So if we look at the first fraction, the 3x squared minus 9x on top, that's going to be a GCF factoring here. So I'm going to go ahead and say 3x squared minus 9x. I can take 3x out of that. And I apologize for the sloppy writing. This is a little bit more difficult in this situation. So I take out 3x, leaving x minus 3 on the top. On the bottom, we have a trinomial. And so we're looking for numbers that multiply to 3 and add to 4. Those numbers are 3 and 1. So the first parenthesis is x plus 3. The second parenthesis is x plus 1. We keep the multiplication in the middle, and we move on to our second fraction. Again, you have a trinomial on top. So we're looking for numbers that add to 7 and multiply to 12. Those numbers are going to be 3 and 4. So we have x plus 3 times x plus 4. Finally, on bottom, again, you have a binomial, and they both have an x. And so that tells us we're probably going to be able to use greatest common factor. So the 6x is the greatest common factor in 6x squared and 24x, which leaves x plus 4. Now comes the fun part. And the fun part's when you get to start just crossing stuff off and saying, what can I eliminate? Well, remember, you can reduce anything on top with anything on bottom as long as they are factored out and they're exactly the same in their factored form. So I see on top and on bottom an x plus 3. So I can factor that out, no more x plus 3. I also see an x plus 4 on the top and bottom. I can factor those out. The x minus 3 and x plus 1, those cannot factor out. Those are going to be part of our answer. But you also see we have this factor of 3x and this factor of 6x. And so both of those can be divided by 3x. So the 3x will completely go away, and the 6x is going to turn into a 2. Because that 6x, when you reduce it by 3x, it becomes 2. So our final answer is going to be what's left. X minus 3 is left on top. On bottom, 2 times x plus 1. All right, that is our simplified form of our answer. And as we've talked about over the last couple of days, there are excluded values in this problem. There are actually 4 of them, but we don't need to state those every single time just for the sake of saving time. You could say x can't be negative 3, x can't be negative 1, x can't be 0, and x can't be negative 4. Those things we talked about limits on our fraction, those still exist. We just aren't stating them in every answer. We did that when we simplified. That showed you understand the concept. We're not going to keep stating that over and over again. So here's your final form of your answer. It's very little new stuff. It's exactly what you did yesterday. We added one little step. Copy dot flop, then you turn it into a multiplication problem, just like yesterday. All right, hope you're all hanging in there at home. Have a great day.